the second question. It says, how much money needs to be deposited now in an account paying 8% compounded quarterly to have a balance of 10,000 after 10 years? So they're asking you when it says how much now, that means what's going to be your initial amount. So your equation would have been 1,000 equals your initial amount, 1 plus 0.08 over 4, that's 4 times 10. Remember, quarterly means 4, not 0.25. And then you wind up solving it through, take care of the parentheses, raise it to the exponent, take 1,000 divided by your answer, you would have gotten $452.89 if you mathed that correctly. Okay. Remember, the word depreciates means it's an exponential decay, not growth. So some of you guys actually flipped that one. So that one wasn't bad though. It would have been 85,000 times the quantity. Let's see, 85,000 times the quantity, 1 minus 0.15 to the 10th. And this gave you 16,734.32. If you math that correctly. The next 5 were pretty quick. You know, the simplified parts, those weren't too bad. You guys did that one just fine. Second page, excuse me. Semi-annually means twice a year. Yeah, it's just like I said in class. You guys, I told you guys you got a semi-annual. Remember, I said, hey, what is semi-annual? Oh, it means 2. What is quarterly? It means 4. So on monthly, 12. These are things that you have to remember. So when you set this one up, it would have been 20,000. 1 plus 0.052 over 2 to the 2 times 3. If you math that correctly, it got you 23,329.97. But then part 2 said if your interest was compounded continuously, the next 3 words say how much more would you have? So the other one would have been 20,000 E, which is the 0.52 times 3. I'm sorry, 0.52. And this would have given you 23,376.52. The difference between the two is $46.55. This is the answer I was looking for. Not that. That's the words. How much? I think I even made mention of stuff like that, but I said, hey, I can ask you the difference between the two. Things like that. The next couple, the main mistakes were made with some rounding errors here and there. They were really straightforward. I think what some of you guys did with your, with the part B though, you changed the year. The year should have been 58 to how many years it was. It wasn't from 2003 because it was going through, because it says at the same rate, what would the house would have been worth today? So if it was still increasing from that beginning spot, that's what that meant. So Montana's are filthy rich. $1.16 million home. No, 1.016. So.
Wait, so for that one, you would 60,000.
And then in parentheses, 1.05 to the 58.
Oh, okay.
Yeah, and that's why you have to hear some of the round. There was a couple of rounding errors here and there, and I was pretty forgiving with how some of those definitely work themselves out to be. I wanted to make sure it was cleanish on that one. Graphing wise, wasn't too big of a deal. I think those of you guys that were having problems with flipping fractions know how to do it now, so it's not that big of a problem. Exponential growth, exponential decay, so those guys have horizontal asymptotes. Logs have vertical because they go from years. Back to the review stuff. Like I said yesterday, I posted on, I think on Fridays was the answer guide and stuff. So you guys should have seen some pretty quick worked out solutions for most of the problems on here. I did not do some of the graphing ones just because quick. But I think there was one. I had all the equation stuff in here. A lot of the equation stuff, as I was going through it, I was just pressing buttons real quick and just kind of rounding them through. So if your decimals were pretty close, you should be okay with those. Yes, Sarah? 8. The equation one? The equation one? Yeah. So, yeah, let's walk through it. Excuse me. So, let's see this guy here. We'll do this, let me get the printer open. This will be calculator, non-calculator. Obviously, this portion right here would have to be with calculator. Word problems will be with calculator. Because you kind of need to use one. So this is our equation 1. So let's see here. So first thing I would have to do in my calculator, I would take the negative 104. I'll take the negative 104 and I'm going to add 6. Okay. So I'll start with that. Negative 104 plus 6 and hit enter. I'm at negative 98. So negative 98 is the negative 8.2 e to 9x minus 4. So now I got to divide by the negative 8.2. So I take the negative 98 divided by negative 8.2. Now this equals the e. Okay? So I have to undo this. In order to undo e, I have to natural log it. So I just hit natural log of my answer and hit enter. This now equals my exponent. So to the exponent now, to get x by itself, I have to add 4 and then divide by 9. So I just hit plus 4, enter, divided by 9, enter. And that's not the answer that I got. I might have hit the wrong button because I did this real fast. So 0.72, is it what you guys got?
Yeah.
Okay. I might have had a mistake. I've never done that before. Don't look so disappointed, so. Yes, sir. Yeah. Same thing with the equation stuff? All right. So on this one here, he's looking at 18, guys. 18 says negative 6 times 5 to the x plus 2 is negative 94. So in this one here, take the negative 94, I can divide it by negative 6 right away. Okay. Oh, did I do that? Oh, I didn't realize I did that. I'm sorry. Yeah, no, I should have divided. I just looked at that going, why did I do that? That's stupid. Yeah, sorry about that. So let's see, do this correctly here. So you're negative 94 divided by negative 6, then hit enter. Then I log base that at 5. So alpha window 5. Bless you. Of my answer. Do you guys know you can put answer in there? Okay. Then you hit enter. So now I just have to subtract 2 from that. Is that what you got? Yeah. Sorry about that. I didn't realize I did that. I'm going to make more than I should. Oh, what else we got, guys? What else we can go through? This is. Sure. Yes, sir. Okay. Which number? Do you remember? 3 or 4. Okay. We'll get you next set. I'll get you. All right. So we're looking at 3 and 4. So we have 27 to the 2x. So in this case here, this one would be the style that you wouldn't use a calculator for. So here you have 27s and 81s, which means you got to get them within the same base. 27 is the same thing as saying 3 cubed. So I know that this is 3 cubed. Oops. times 2x. 81 is 3 to the 4th. But I'm going to write it as 3 to the negative 4. Okay. Are those bases the same?
Yeah.
When the bases are the same, you can just set the exponents equal to one another, and you wind up with 6x is negative 4. X is negative 4/6, otherwise known as negative 2/3. Nope. Nope. And then 4 is very similar to that, where you just have to flip the 8 to a negative, make it a negative 1, 8 to the negative 1. So you have 8 to the x plus 2 would equal 8 to the negative 1. Again, those bases are the same, so the exponents, you can set the exponents equal to each other. See,
I'm just saying, like,
you would do the same thing.
because I did that accidentally.
Yeah, no, it would work the same because technically that's what you are doing.
Oh, okay.
But once we know we have the same base, you can just show them drop through, okay? I'll make it Autumn get yours in there. Autumn, what you have?
Can you number 16 on that?
Yeah. On the equation sheet, is that the log base 9?
Yeah.
X squared. Excuse me. So we're at number 16 on the other equation sheet where it says log base 9 x squared plus log base 9 6 is 2. In a problem like this, before you can go anywhere with it, you have to condense the log. Okay? So you have to condense the log first. So you wind up with x, you get log, excuse me, base 9 of 6x squared is 2. Now you have to undo the log. Undo the log, we have to exponentiate it. Okay? So you have a 9 to the log base 9 of 6x squared is 6x squared. And this becomes 9 squared on the other side, which is 81. Okay. Now to solve for x, we just divide out. So x squared is 81 over 6, and then we square root it. So you get x is plus or minus 9 over the square root of 6, which means I have to rationalize it out. So you multiply top and bottom by root 6, you get 9 root 6 over 6, excuse me. And you can simplify that, and you get 3 root 6 over 2. And that's plus or minus. And then again, in this case, the plus or minus would be okay. Bless you. Bless you. Bless you. Because you've got a squared thing, so when you negative, you square negative, you'd be all right. I think I might have simplified that a little bit differently. Yeah, I did 81 over 6, and I got the 27 over 2, and I simplified it that way. It works the same way. It doesn't matter. Grace, what did you get for this next? Sorry, excuse me. So 5 back on the review sheet, it's rewriting. You've got y to the negative 9 is x, and it wants you to write that in log form. So that means you've got log base y of x is negative 9. Any what you got? Sure. So when you do inverses, and this is one of the things that a lot of people are still messing around with. Is it? Wasn't it on there? For 11 and 12?
No, that was another for 21.
Oh, I apologize. I thought it was on there. I might have got. I wonder if it got cut off because I have it on here.
But like it wasn't there for either.
Okay, that's fine. It might have been scanned badly. We'll go through it real quick. So when you're doing inverses, so this is 11. When you do inverses, it never changes the first step. First step is always flip-flop x and y. Okay? You always flip-flop x and y. And you get x, I'm going to write it as negative 1 log base 4 of y. So before I undo the log, I gotta remove the -1. Basically means just multiply both sides by -1. So you get -1x is the log base 4 of y. Either one's fine. It means the same thing. So now to undo the log, you have to exponentiate 4, yeah. So 4 to the -1x is y, is your input, or 4 to the -x. Either one of those is fine. 12 is the same thing, where you flip-flop your x and y first, and you resolve. So you had y was the log base 6 of x plus 5. So flip-flop x and y, and you're going to get x is the log base 6 of y plus 5. You can't do anything about the log until I move the 5. So what do you do with 5? Subtract. So now you have x minus 5 is the log base 6 of y. Now you have to 6 it. Yep. So your answer is 6 to the x minus 5 is y. And then, Sarah, you were saying 21 and 22 didn't show up?
Yeah.
Okay. So 21 and 22 are basically the same thing, just going the other direction, starting with the exponents, going to logs. So in 21, again, first step, flip-flop x and y. And now to undo the log, you have to 2 it. So 2 to the x is 6 to the y. And now I gotta get the y to drop, so now I have to log it. So you log base 6 of 2 to the x is y. 22, very similar. Starting with y is 2 to the x over 4. So x is 2 to the y over 4. So we got to work backwards. Multiply both sides by 4. And now what log base you have to do? Log base 2. So you get log base 2 of 4x is y. On the evaluate?
On the review.
Yeah, that'd be a non-calculator. Log base 2 of 64. I mean, when I do log base stuff like that, I always try to make sure that the log base ones are easy to work with. I don't know if you've noticed that it's usually log base 2, 3, or 5. You know, I don't, and then the numbers work pretty decently. And again, that's not terrible. Because you have a 6, and you're like, okay, well, we know it's not a 3, we know it's not a 4, we know it's not a 5, let's try 6. Because 6 times 6 is 36. Multiply it by 6, it's always going to end at 6. So that's the whole trick with the 30s, with the 6s. Yes, ma'am.
Can we go over the loss graph?
Sure. So when you're graphing logs, so whenever you graph logs, the only things you can plot are going to be your base, comma 1, and 1, comma 0. All right, your parent function will always be base 1, 1, 0. Okay? No matter what. In this case, what's your base? 1/2. So I know my parent would be at 1/2 and 1, and then 1 and 0. The shift is your h and k. Well, our h is 2, our k is -4. So x plus 2, y minus 4. That gives us ordered pairs then at 2.5, -3, 3, -4. Okay. Logs come from what? Trees. Trees grow which direction? Up and down, which means they have what kind of asymptotes? It's the dumbest thing you're going to remember, though. All right, so you have vertical asymptotes. Vertical asymptotes start at 0 with a parent, and then it shifts to your h. So when I graph it, my parent functions at 1/2 and 1, 1 and 0. So that means it's moving this way. I shift that, it has a new asymptote then at 2. So I'm at 2.5, -3, and then 3 and -4. Yes. So your vertical asymptote is at x equals 2. Your domain for logs is always x is greater than your asymptote from the shift. So domain, x is greater than 2. Your range is all real. It's flipped from what it would have been with exponential. And that's what those look like. Log graphs should be pretty quick and easy. At least I hope they are. Does that help then? Andy, what do you got? Yes. Yep, vertical asymptotes always can be at 0 for, bless you, will be at 0 for the parent function for these. Just like they were at 0 for exponential, but those were horizontal. What else we got? Good rapid fire. Oh, one second, I can't hear. Oh, number, yeah.
Okay, yeah, so like for 24, the logs just like cancel each other out, right? And then you just set them equal.
You just set them equal to each other. You want to put quadratic that you have to just make sure they work. And the quadratic works pretty cleanly in that case. What else we got? So if you are condensing or expanding, I'm looking at 15. 15 is an expand. I'm starting with log base 4 xy squared to the 6th. Remember, a real easy thing to think of if you're expanding, however many logs you need is how many variables you have. Okay, that's a nice little trick to remember. So in this case, there's 2 variables, which means I need to have 2 logs. Everything else just kind of falls into place. Now, in this first one, notice how both variables are grouped with parentheses with the 6 as an exponent. That means I got to pull the 6 down in front and put everything else in parentheses. So the first one is going to be log base 4 of x. These guys are being multiplied. And then since the y has an exponent, I can put the 2 log base 4 of y. And I'm done. And a lot of times what some of you guys will notice is if you wrote it as this first, and they're like, oh, I can go further, you just usually erase it and put it in front, and that's fine. And that's what that would look like. And then if you're condensing, where's it condensing? Condense. This stuff's all out of order. What was it? be. What else we got? When you went back and looked at the packet O word problems, what do you got? I'm pretty sure we went through the majority of all of these already together anyway. It was all, growth decay. I was trying to steer clear of some of the bacteria stuff, but for the most part, we've done pretty much every one of them that I had. Are we good? Oh, no, I'm not feeling good. What else do you want to look at? Sure. You could look. Yeah. Oh, excuse me. Which one?
No, I just think. So for like this one? Oh, because those are multiplying, so that's why you're adding. And then this stuff.
Mr. Murphy, what is he talking
Why is Chucky attacking the bird?
I don't know right now.
Nice. Glad to see Chucky's out there. We're trying to build this.
better than him?
I don't think I ever saw one of the Chucky's movies. I just
I'm not
I've never been a big horror fan. I've seen a couple of them, but I'm just like, what else we got? What do you got? Which one? 24? So 24, in order to solve this one out, you've got log base 14 of 3x squared plus 14x log base 14 of negative 45 plus 2x squared. So in order to make this one work, basically what happens is since you've got the same log base on both sides of the equation, you could 14 it and everything would drop. So you don't have to do that because you know that this has to work. So you just wind up doing 3x squared plus 14x minus 2x squared plus 45 and set it equal to 0. Okay. And then from here it goes pretty quick. X squared, 14, 45, you get 9 and 5. And since you're squaring it, they both should work. Those should both work themselves out. Take a look at 28 though real quick. 27 and 28 are ones that I know that people also for some reason freak out when they see. So oh, it did work? I didn't double check. I just saw the negatives. I thought they would go through. Oh yeah, that would work. So you get the negative on the left hand side there. Yeah. So negative 5 on that one didn't work. Yeah. So if I'm looking at 28, in order to solve this first, you have to condense. So there's going to be times where you have equations that you have to condense before you can do anything, and this is one example. We wind up then with the natural log of 30x is 3. Okay. Now, to undo the natural log, what undoes natural log? E. So you have to E it. So you have 30x equals e to the 3, and that's where you get x is e to the 3 over 30. No, it's e, it's not imaginary. Wrong vowel. I know, right? Just wait, it gets better. We get the trig, we start doing trig identities, it's just a lot of sines, cosines, secants, and tangents and stuff.
They're also uniform.
There are not any unicorns, but if you feel like you want to draw a unicorn every once in a while, that's okay. It might make you feel a little bit better. But yeah. What else? This is your time.
Are we gonna get it?
That's all I got. 13 of the equation? Sure. Well, that's a good one. So, this is 13 on the equation sheet from the other day. This is log base 8 of 2x squared minus 7 minus the log base 8 of 5 is the log base 8 of 13. Well, before you can drop all the equation stuff, you have to condense the left-hand side. Okay? So when you condense the left-hand side, you wind up with log base 8 of 2x squared minus 7 all over 5 is the log base 8 of 13. Now the log bases go away. Because basically what happens is you're 18 both sides. All right. So you wind up with 2x squared minus 7 equals 65. Okay. Then it's multiplied by 5. So now you have 2x squared is what, 72. X squared is 36. You have plus or minus 6. Negative 6 in this case should be okay because you're squaring it just here. There's no other x.
Yeah. Yeah.
Where you got? Same thing? Sure. So 14, same principle. Log base 5 of 10 minus log base 5 of 4x plus 9 is 2. You have to condense the left-hand side. You wind up with log base 5 of 10 over 4x plus 9 is 2. So you have, in this case, you have to divide both sides. So you have 10 over the 4x plus 9 is 25. Gotta do some cross multiplying here. So let's see, we have 10 is 100x plus 250, 225, I believe. Is that right? I don't know, whatever it is. Yeah, that's right, 225. And then just work backwards. See, we have 100. Let's see, 100 minus 220, 10, excuse me. And then we have to divide that by 25. I think mine simplified. Oh, you know what I did? Okay. So I have negative 43 over 5. What I did here was I just flip-flopped them. The 10 over 25 was 4x plus 9. That's another way of doing it. And then I wonder if I typed it in incorrectly in my calculator. I probably made an error when I typed mine in. But yeah. I did? Oh, that's all right. So that's probably what I did there. So my answer was probably right then. And then this was divided by 100. Yeah, really good. I was right. Excuse me. Oh, I feel like I've done 1,000 billion sit-ups. The cops. Even the cop, no, he's.
Are you sure you did? No, you might have. And that's why you're feeling.
That's pretty much how it was. Yes, sir.
Walk the flag, Tim on the radio the other day. I love the one.
That's awesome. That's awesome.
Like the Terminator one.
Terminator was very funny.
Oh, on Saturday, I went to Los Angeles, and I was at CJ,
Yeah,
and that song played.
that's great. What else we got? Anything good? So tomorrow we'll test. Tomorrow we'll test everything. On Thursday, even though we have the short day, we will start the trig stuff, which means we start right triangles again. So everything you remember about right triangles, and solving right triangles, SOHCAHTOA, special right triangles, all that stuff. It's basically all comes back in one day. And go from there. What's that? So yeah, SOHCAHTOA, right? Make sure your calculators are here on, especially tomorrow and on. Really, after that, we kind of do a lot of other stuff with the next year. And then we do a lot of trig about it. So, good times. No, I'm good, thanks. Again, that would require me carrying money. I don't carry any money. No reason. Yeah, here you go. Oh, excuse me.